Okay, now we move to the nucleophile and electrophile. The page is given here. Okay, for the 5th edition, 123. Okay, let's look at to the description. Okay, electrophile are the electron lover, or they are also what we call as the electrophilic reagent. Okay, so what happens is when they are electron lover, they will attack the negatively charged carbon atom. Okay, when they attack negatively charged carbon atom or the carbanion, okay, then they will accept the electron. They will receive the electron during that process. Okay, and they are also known as the Lewis acid. Okay, we'll discuss what is the Lewis acid later in the topic of the acid and base. Okay, and then the electrophile can be any positive ion, okay, or any molecule that are deficient in the electron, that do not achieve octet. Okay, example of the electrophile are free radical, carbocation ion. We have discussed these two, radical and carbocation ion. And then any positive ion, H plus, H3O plus, okay. And then BF3. Okay, why BF3 is one of the electrophile? Okay, you have learned, you have found this BF3 before in your Chem 1. Anyone can answer me why it is considered, it is categorized under electrophile?
Because it want electron to become octet.
It what?
It want electron to become octet.
One electron to become octet. Why it one electron to become octet?
Deficiency, deficiency of electron kan.
Okay, because it is one of the electron deficient molecule. Remember when we discuss on the molecules that do not achieve, that do not obey octet. Okay, the special case, we have expanded octet, we have electron deficient molecule, and also we have odd electron molecule, right? So BF3 is under the electron deficient molecules. If we draw the structure of the BF3, same goes with the BH3. We'll observe that the boron as the central atom only has 3 pairs of electron around it. And we accept this as the correct structure of the BF3. Okay, because this boron can become the electron deficient molecule, but it is not happen for the carbon, sulfur, and so on. Okay, only special or specific atoms that can do not achieve octet, but we accept the structure as the correct structure. So when the boron, okay, do not achieve octet, it will make the molecules become electron deficient molecule, and it is under the electrophile. Okay, now we move to the nucleophile. They are nucleus lover, sometimes called as a nucleophilic reagent in a reaction. Okay, when they are in a reaction, we say that, oh, this is a nucleophilic reagent. Okay, and what happened is the nucleophilic reagent or the nucleophile will attack the positively charged carbon atom. Okay, and when it attack the positive charge of the carbon atom or the positive species, and they will donate, okay, and they will use their electron to form the dative bond. Remember dative bond, covalent coordinate? Okay, and they are often the Lewis base. So any negative ion, okay, or molecules that have at least one lone pair, okay, the one that are rich in electron, okay, either they are the negative ion or they have a lone pair, then they can become a nucleophile. Okay, so example of the nucleophile, an ion, carbanion, okay, OH minus, this is a negative species, carbon-carbon double bond. Okay, when we have a alkene or alkyne, carbon-carbon double bond, carbon-carbon triple bond, or when we have a H2O, when we have a ammonia, okay, they are all nucleophile. Okay, why carbon-carbon double bond become a nucleophile even though it is neutral? Okay, because the carbon-carbon double bond is considered as the electron-rich species. Okay, because it has 2 pairs of electron here. Okay, if we compare between a person that have only one car with the person that have two cars, okay, we still consider that the one that have two cars is richer than the one that have a one car. Same goes with this carbon-carbon double bond. And then for the case of the H2O and ammonia, okay, it is because they are having lone pairs. H2O, if we remember back the structure of the H2O, okay, there are two lone pairs at the oxygen. So that oxygen will use its lone pair, okay, this electron, to attack the electrophile, okay, to start a reaction. As for the ammonia, nitrogen are having one lone pair in their structure, okay, that are on the electrophile and nucleophile. Okay, now we move to the type of the organic reaction. Okay, there are several types of the organic reaction. Okay, let's start with the first one, which is the substitution reaction. So this substitution reaction is a reaction when we have atom or group of atom that is replaced by another group of atom. Okay, the replacement occur. So if we look at to the example of a reaction that is happen here, this carbon initially bonded to Z. Okay, and then this compound is then reacted with Y. Okay, and then it suddenly produce C that is attached to Y, in which in this reaction what is happen is Y is replacing Z. Okay, so Y come in, Z come out. So in general, when we look at to this reaction, we know that this is one of the substitution reaction. Okay, when the atom or group of atom is replaced by other atom or replaced by other group of atom. This substitution reaction. And this is the reaction that we have discussed, okay, during our first class. When we have a saturated compound, they cannot undergo addition, but they can have this substitution reaction. Okay. Substitution reaction will involve, okay, the sigma bond. So one sigma bond breaks and another one form, okay, with the same carbon atom, of course. So the most common example of the substitution occur when Z is a hydrogen, okay, or any heteroatom that is more electronegative than the carbon. So example is here when we have a iodomethane, CH3, I, this I is actually attached to this carbon. Okay, so iodomethane is reacted with the chloride. Okay, so what happened is chloride replace iodine, so it turns to chloromethane. Initially, it is iodomethane. Now it turns to chloromethane. Chlorine replace I, so this is the substitution reaction. Or the substitution reaction also can occur in this acyl chloride. Okay, remember acyl chloride? This is the haloalkane family. This is acyl chloride. Okay, C double bond O, Cl. Okay, acyl chloride react with the hydroxyl. Okay, and then the hydroxyl replace chlorine and suddenly it turns to the carboxylic acid. Okay, from acyl chloride turns to carboxylic acid when this chlorine is replaced by the OH group. Okay, so these are example of the substitution reaction. Now, the second type of a chemical reaction, okay, is the elimination reaction. Okay, elimination is a reaction in which element from the starting material are lost. Okay, the element from the starting material lost, and then the pi bond form. That is the elimination reaction. So we have here C that is bonded to C, and each carbon are having X and Y attached to it. Okay, when this compound reacted with a certain or specific reagent, okay, suddenly, okay, no more X and Y attached to these two carbon, okay, and in order for these two carbon to achieve a pair, they are forming the new bond or the second bond with them. They are forming a pi bond. So X and Y that come out, okay, are forming new bond with them. Okay, it is not necessarily that the one that come out form bond or they are forming the new compound. Okay, with them, not necessarily. But this is just an example that is given Okay, it is also possible for X and Y to form bonds so that it turns to XY molecule. Okay, but we are focusing on the starting material and then the main product. Okay, when we break two sigma bond and we form one pi bond during this elimination reaction. Okay, so during the process, sigma bond are broken, pi bond form. Okay, example is given here. Look at to this. This is the haloalkane. Okay, when we have a bromine here, okay, with two carbon. Remember how to give name to this molecule? Identify the parent. Okay, with two carbon, so it will be ethane. Okay, and then we have a bromine here, so that the name will be bromoethane. Okay, so when you have a bromoethane, react with the OH minus. Okay, this is the reagent that we use. And then H and B are lost so that it will form from bromoethane, it turns to ethene when the pi bond is formed. Okay, so H come out, bromine come out. And then the next example here, when we have a alcohol, okay, this is cyclohexanol. Okay, we have a OH and H from the adjacent carbon, from carbon sebelah-sebelah, from the neighbor carbon, okay, is lost. Okay, they are lost. Then what happened? These two carbon, when they breaks their sigma bond, they will become they are not octet, right? So in order for them to be octet, then they form the pi bond with them. And now it turns to cyclohexene. Okay, next, the third type of a chemical reaction is the addition reaction. Okay, it is a reaction in which elements are added to the starting material. So if we have a starting material here, carbon-carbon double bond or the unsaturated compound, okay, the pi bond are broken first. Okay, we break one pi bond, okay, and then X and Y being added to both of the carbon. So one carbon will got X, another one will got Y. Okay, so pi bond break, new sigma bond form. Okay, this is the addition reaction. Okay, so example is given here when we have this ethene, okay, reacted with the HBr. So pi bond broken, H attached to the first carbon, Br attached to the second carbon. Okay, so from alkene it turns to haloalkane. Okay, and then this is the cyclohexene. Okay, as what we have observed before, we have discussed cyclohexene before. Okay, react with the H2O. So this pi bond broken, and then both of the carbon receive H and OH. So it turns cyclohexanol. Okay, one carbon receive H, another one OH. So pi bond broken, new sigma bond form. So if we look at these two type of a reaction, addition and elimination. We start with the elimination just now, right? Okay, when X is eliminated, X and Y eliminated, so it will form alkene. Okay, and then from alkene, X and Y being added, okay, then it turns to this compound. So basically the elimination and the addition are opposite reaction. Okay, so if we look at here, okay, this is the example of the substitution reaction. When we have a cyclohexanol, suddenly we have the bromocyclohexane, okay, in which hydroxyl is replaced by the bromine. Okay, and then from cyclohexene, it turns to cyclohexane. Cyclohexene turns to cyclohexane. Okay, this reaction is actually the addition reaction. If we try to expand the structure, actually here we have a carbon with one hydrogen. Okay, why only one hydrogen? Because they already form this double bond. Okay, when it is undergo addition reaction, so what happen is actually each carbon receive the second electron. Okay, that is why it is addition reaction. And then look at to this. Okay, we have 1, 2, 3, 4. 4 is butanol. Okay, 2 because hydroxyl is at carbon 2, so that the name will be 2-butanol. Okay, so 2-butanol. Okay, suddenly it produce, what is this class?
Butene. Madam.
Okay, it produce 2-butene. Okay, we have to have number at the front because it is possible as well to have a double bond here for butene. Okay, there are two possible position of the double bond. When it is butene, it's either it is 1-butene or 2-butene. So we have to give number at the front. Unless there is only one possible position. For example, when we have propene kan. Okay, when we have a propene, double bond dekat situ pun masih lagi 1 propene. Okay, or double bond dekat sini pun 1 propene juga. We will start with this carbon as the first carbon. Okay, since that we have only one possible position, so we don't need to have a number at the front. Okay, but once we have more than one possible position, the number is compulsory. Okay, so from this two butanol, okay, it turns to this 2-butene. So what happened is the hydroxyl, okay, and also H here, one of the H here that we can't see because this is a skeletal structure. Okay, but let me draw it for you. Okay, the carbon there are having two hydrogen attached to it. Okay, while this carbon only has one hydrogen and one hydroxyl attached to it. So this hydroxyl, okay, come out with the hydrogen from the neighbor atom, the neighbor carbon. Okay, so that it turns to this alkene. So it is undergo elimination reaction. The next type of a reaction, okay, is oxidation reaction. So this oxidation reaction is actually a reaction, okay, that we can identify when we observe that they are hydrogen atom that is lost or oxygen atom that is added, okay, to the starting material. It means that the product will have less hydrogen or more oxygen than the starting material, or it also can happen both. Okay, H is lost and oxygen is added. Okay, either one ataupun dua-dua berlaku sekali. And this oxidation is occur, okay, when we react a substance with the oxidizing agent. This OA is actually the oxidizing agent. Okay, any substance that we react it with the oxidizing agent, so this oxidizing agent will help this, or it will make this substance to be oxidized. Okay, and the most common oxidizing agent are KMNO4, potassium permanganate, or the K2Cr2O7, potassium dichromate. Okay, example of the oxidation reaction when we have a primary alcohol. Okay, the primary alcohol, we'll discuss later how to differentiate primary, secondary, or tertiary alcohol. It is oxidized, turns to carboxylic acid. Okay, primary alcohol oxidized to carboxylic acid. Or if we have a secondary alcohol, it is oxidized, turns to ketone. Or it is another example, if aldehyde that is oxidized turns to carboxylic acid. Okay, let me try to
Madam,
give you the example.
madam,
Yes. Yeah.
yang second,
Okay, example of the primary alcohol that is turns to the carboxylic acid. If let's say we have a propanol, CH3, CH2, CH2OH. Okay, react with the oxidizing agent. Okay, it turns to CH3, CH2, C double bond O, OH. Okay, from alcohol turns to carboxylic acid. Okay, or for secondary alcohol, CH3, CH, OH, CH3. Okay, react with the oxidizing agent. Then it is then turns to CH3, CH double bond O, CH3. Okay, so look at to the difference between the starting materials and the product here. Okay, what's the difference between these two? This product are having
Different functional
more
group.
oxygen. Memang different functional group. During the oxidation ni, these are the things that is happen. Okay, I told you that alcohol tends to carboxylic acid. Of course, that different functional group. Okay, but if you look at to the product, okay, it is actually having extra one electron, one oxygen. Here we have only one oxygen. Okay, when it turns to carboxylic acid, it has extra one oxygen. It start to have two oxygen. Okay, see, this is one of the criteria of the oxidation process. And then if you try to look at to the hydrogen, please check the hydrogen. Are they having the same number of hydrogen before and after the reaction occur?
Oh, they lost hydrogen.
No, lost
Yes.
hydrogen.
This carbon lost one hydrogen. Okay. COH. It lost two hydrogen actually, right? Okay. So hydrogen loss and oxygen added. And then in this case, this is the example of secondary alcohol. Okay, it turns to ketone. Turns to ketone. Actually, no more H here. Okay, so what happened when it turns to ketone? Any addition of oxygen? Extra oxygen ke?
No,
No, they
No.
lost hydrogen.
they
Yes.
lost two hydrogen.
Yes. Oxygen are the same, but the number of hydrogen is reduced. It's less than before. It lost two hydrogen. Okay, so that's the criteria of the oxidation. It is not necessary that they will occur simultaneously. Okay, sometimes it is occur simultaneously in this case. Okay, as for this, they are just lost the hydrogen. Sometimes we just observe that, oh, oxygen is, we have oxygen more in the product than the reactant. Then the next type of a reaction is the reduction reaction. Reduction is opposite to the oxidation. So the product, okay, of the reduction process, okay, will have extra in the hydrogen and less in oxygen. Okay, gain hydrogen, loss oxygen. And then in order for the reaction to occur, okay, the substance need to be reacted with the reducing agent. Okay, the most common reducing agent that we'll use after this. Okay, we have more than this actually. Okay, but the most common that we will use example of the reducing agent as is, okay, LiAlH form or an ABH form. Okay, example of the reduction reaction is when we have a carboxylic acid is reduced to primary alcohol. Ketone is reduced to secondary alcohol. This is actually the opposite reaction of the one that we have discussed here. Okay, when the carboxylic acid, it can turns back to the primary alcohol. Okay, ketone turns back to the secondary alcohol. Okay, then it will be opposite. So here we have no hydrogen at the carbon. Okay, when it turns back to the alcohol, it has extra hydrogen. Okay, so same goes with the first example. Okay, and then the last type of the chemical reaction is the hydrolysis reaction. Okay, hydrolysis reaction is any reaction, okay, that involve, okay, the reaction with the water and the water undergo cleavage. That is the hydrolysis. Okay, cleavage of a chemical bond by the addition of water. The reaction that involve water and then the water undergo cleavage, okay, is known as a hydrolysis. Okay, so how many type of a reaction that we have discussed? Class
Three.
6.
Six.
3.
6,
Start
madam.
with the first one. Yeah, start with the first one. What is the first one?
Substitution.
Substitution.
Addition.
Elimination.
Elimination.
Addition.
Addition.
Oxidation.
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 Reduction. Hydrolysis.
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 And finally, hydrolysis. Okay, so sometimes the chemical equation is given to you, then you have to identify what is the type of a reaction that is occur in that chemical equation. Okay, any questions?